Alright, welcome to the notes on 2.4. This is more about linear equations. Again, stuff review from Algebra 1, so it should seem familiar to you. If you have questions as we go, make sure you jot them down. Ask me in class or your teacher or strangers on the street or whatever for help on these kind of problems, okay? So, let's take a look. The essential understanding part right here, we need to have a grasp on, okay? The slopes of two lines in the same plane indicate how the lines are related, all right? So that's a good drawing. And all that's talking about is so that we can compare two lines. The slope is a really good starting place for that comparison. There was a way of writing equations of lines that you learned about in Algebra 1 called point-slope form. It's named that because math teachers are really creative. And so all you need for it is a point and the slope. It works because it's derived from the slope formula, and that's what this shows right here, that if we took the slope formula and we just manipulated it a little bit, multiplied both sides by something, and then divide both sides by something, that you can get the slope formula to transform into the point-slope formula of a line. So let's look at how we can use this. First, just real simple, writing an equation given a point and the slope. Don't overthink this, guys. This is as easy as it gets. What you need to memorize is the formula. Okay? So it's y minus the y value equals the slope times the quantity of x minus the x value. So we have this point right here. We plug the -5 in. It's always minus, so you know it's okay to have 2 in a row. That'll change to a plus later on. And then it's -2 here, and then the slope goes out front. There's no need to distribute it because we want to look at it and be able to say, all right, this line has a slope of 3/5 and it goes through the point -5, 2. So we don't want to distribute. You just want to leave it like that. So take a look at this one right here. What's the equation of the line through the point 7, -1 with a slope of -3? Real simple, okay? Y minus the y value, which is -1, so we can go write y plus 1, is the slope times x minus the x value. And that's it. Okay? Do not overthink this stuff, guys. This is as easy as it looks. Problem 2, writing an equation given 2 points. Well, what we know is 2 points. What we need is a point-slope form, so we need to find the slope. Okay? We need to find the slope. So it's difference of y over difference of x, and then, you know, make sure you have the signs right. And once you find the slope on this one, it's 3, and then you can pick either set of points. You could pick 3, 2, or they could have picked 5, 8. Either set of points works. It doesn't matter which, okay? So let's take a look at the got it here. A line passes through -5, 0, and 0, 7. What is an equation of the line in point-slope form? So let's find the slope first, right? So the slope is, and I don't know, for those that have seen other videos that I've done, I don't like the slope formula. I'm not a fan of it. I much prefer this formula, the delta y over delta x. Delta meaning is a Greek letter, and it means change. So I always give myself a quick sketch. So -5, 0 is here, 0, 7 is there. So now I know, because it's going up, that the slope is positive. All right, so I have a positive slope. And then the difference between the y's, well, from 0 to 7 is 7, and from 5 to 0 is 0, or is 5. So that's the slope. Slope equals 7/5. Okay. Now what I can do is I just pick one of these points. So let's say I pick the first point, -5, 0. Well, it's y minus 0 equals the slope, which is 7/5, times x minus the x value, which is -5, so it becomes x plus 5. Now I can take that one step further and write, because I know what y minus 0 is, it's y. So I can just write y equals 7/5 times x plus 5. Okay? Now I could have chosen the other point and that would have been fine. Alright? If I want to choose the other point, I have y minus 7 equals 7/5 times x minus 0. again, I can simplify this because I know what x minus 0 is. I could write y minus 7 equals 7/5 x. Okay. Now, what is another equation in slope-intercept form of the line to the 2 points? Yeah, that's what we just did. Sorry, in point-slope form. We did the red part. I did it without telling you, but this red part that we just did down here, that was part B. So I just moved that down there. That was part B. So we have two different ways to write this equation. All right. Another form of the equation of line is commonly called standard form, in which the sum of the x and y terms are set equal to a constant. When possible, you write the coefficients of x and y and the constant term as integers. So we would like them all to be integers, okay? But this is ax plus by equals c. Again, this is review from Algebra 1, so you've seen this before. Ax plus by equals c. They need to all be integers, and a needs to not be negative, okay? So let's take a look here. So what we have to do sometimes is transform this, which is given to us in slope-intercept form. That's slope-intercept. And we need to transform it to standard form. So we have to be able to manipulate the equation. We know that we want it ax plus by equals c. So we get the x's and the y's on the left. Got that. Then we have to get rid of the fraction. Now, the book leaves it as -3. You know, big picture, that's fine. I think sometimes you'll see that, sometimes you won't. That's more of a personal preference, and me personally, I wouldn't, but we'll take it, okay? But no fractions, so you have to multiply everything by 4. Pretty simple. Let's take a look at this one. Y equals 9.1x plus 3.6, okay? So let's do this. Let's subtract 9x from both sides. So now we have negative 9.1x plus y equals 3.6, and then we need to get rid of this decimal, okay? Easiest way to do that is to multiply everything on here by 10, all right? So we can just say negative 91x plus 10y equals 36, and now I have no decimals. I do have a really funny looking plus sign, so we'll clean that up. So there you go. Concept summary, if I were a note-taking type, I would always make sure that I took note of this part right here. I think these concept summaries are important, things that you need to know. Slope-intercept form you should know, point-slope form, that's from today's notes, but again, Algebra 1, and standard form from today's notes, but also Algebra 1. So let's take a look how to graph an equation using intercepts. There's lots of ways to graph an equation, okay? The easiest way to graph it is different every time, though, because it depends on how the equation is given to you. If an equation is given to you in standard form, a really easy way to graph it is to graph it by using the intercepts. So to find x, let's start with actually, to find the y-intercept, you make x 0. That is some of the ugliest handwriting I've ever seen. So to find the y-intercept, you make the x 0, all right? That's slightly better. To find the y-intercept, you make x 0. And to find the x-intercept, you make y 0, okay? So, which should make sense because the y-intercept, the value of x in that coordinate is 0. So that's how we find it. So that's all they've done here. They make the x 0, they solve for y, boom, you put a point. Here you make the y 0, you solve for x, boom, you put a point, you connect them because playing connect the dots is fun, and there's your line. So let's take a look. If you take a second, find the x and y intercepts of this equation while I bring a graph over onto the screen. So find the x and y intercepts and then we'll graph it. If you need to pause the video, pause the video. Alright, so to find the x-intercept, we make y 0, so this is gone, that's 0. 2x equals 8, so x equals 4. To find the y-intercept, you make x 0, so that's 0, so then we have negative 4y equals 8, so y equals negative 2. Alright, so here's y at negative 2. Here's x over here at 4. And then my straight line through those 2 points is right there, and I put my little arrows on it because I like drawing arrows. And there's my line, no problem. Drawing and interpreting a linear graph. So now not just drawing it, but being able to glean, good word. One syllable good words are tough to come by. Glean is a good one. We need to be able to glean some information, get some, learn some, infer some, something. Some information from the graph. So what graph models the situation? First, you find the number of chirps per minute. Okay. Then we're going to let x equal this and y equal that. We plot some stuff. We draw a line. We get the equation in standard form. All sorts of different questions here, but all things we know how to do. Okay. If the temperature is 70, how many times would a cricket be expected to chirp? So then we're using, the equation that we've got to make an educated guess on something else in the future. This is good stuff. All right, good stuff. So, the office manager of a small office ordered 140 packs of printer paper. Based on average daily use, she knows that the paper will last about 80 days. What graph represents this situation? And you can just sketch this if you don't have graph paper. So we need the graph, we need the equation of the line in standard form, and we need how many packs of paper should the manager expect to have after 30 days. Go ahead and pause the video here, see what you can do on this problem, and then unpause it, and I will help you out. Alright, so here's what I got for my quick graph here. It looks like this. The equation in standard form looks like this. And after 30 days, I would expect there to be about 87.5. So here's how I got, people jump out right away, 560. How'd you get that number, right? So let's take a look. What I have right here is I have the y-intercept. So I could start this out by saying y equals, the y-intercept is positive 140. I'm going to use slope-intercept form, and then I'm going to transform it, okay? And then what is the slope? Well, I need to know what the slope is. I know it's negative because I can see the line going down. So what I can do is the slope of this line is the change in y, which is 140, over the change in x, which is 80. So the slope is 140 over 80. So I want to reduce that, okay? If you're not sure how to reduce that, let's take a look in our calculator. I'll do it in a TI today. We'll check the TI on and practice our reducing. So I have 140 divided by 80, and it gives me a decimal, which I don't want because it's slope. I want the fraction. So in a TI, if I hit math, enter, it changes it to a fraction for me, and there it is as 7/4. Okay, so negative 7/4 x. Now, to change this to standard form, all I have to do is add 7/4 x to both sides. So 7/4 x plus y equals 140. And then if I multiply everything by 4, I get that. All right? Down here, to figure out what about after 30 days, all I have to do is take the equation that I found. It doesn't matter really which one. I'm going to go ahead and just use the slope-intercept one because it was the easiest. Less math. 30 days. Well, the days were the x values. So if I say y equals negative 7/4 times 30 plus 140. So let's go right back into our TI. And we have this 7/4. We're going to make that negative 7/4. Okay, that times the 30. And then plus 140. And there's our answer of 87.5. Okay? Let's take a look at the next page. If that didn't make sense to you, make sure that you write something down so that you can be helped when you get to class. Key concepts, again, here, this is hopefully stuff you remember from Algebra 1, but if you don't, I would be writing this down, check this. Slopes of parallel lines are always the same. Slopes of perpendicular lines are opposite reciprocals. Opposite reciprocals, okay? Yeah, that's pretty much it. We worked a lot on this in geometry. You work a lot on this in Algebra 1. So what is the equation of each line in slope-intercept form? So a line parallel to this, it's going to have the same slope. So then I plug that slope in, I use point slope formula, and then I transform it to slope-intercept form, okay? Perpendicular lines are going to have opposite reciprocal slopes. So the opposite reciprocal of negative 4 is positive 1/4. Then I use this point, I use point slope form, and then I transform that to slope-intercept form. I know this stuff is not easy, and I know that sometimes we struggle to remember it from Algebra 1, but it's good practice, and it's a good thing to remember. Go ahead and pause the video here, see if you can do example 6 or problem 6 on your own, and then unpause the video and we'll check it together. Pause the video now. All right, so here's what I got. On part A, I started with the equation. I transformed it to slope-intercept form so I could find out what the slope is. Now, some of you may have had a teacher that showed you this, and this is good information. In standard form, the opposite of A over B equals the slope. So if you look at this, this is A, this is B. The opposite of A over B equals the slope, and sure enough, the slope down here is -2. So I have that. You can do that, or you can transform it either way. So then I'm going to plug the new point, this point up here that they gave me, okay? I'm going to plug this, and the slope that I found, because they're parallel, they're the same, okay? Plug those into point slope form, and then it's 2 steps, distribute and then move, okay? I'm going to distribute this to everything in here, and then I'm going to move the 2 to the other side by subtracting it, and this is my answer, all right? Same thing, but different. Over here, I have this line. It's perpendicular, so I know that the perpendicular slope is -3/2. I set it up in point slope form. I distribute anything times 0 is 0. I add my 6 to the other side, and there's my answer. And that's it for the notes, guys. We'll do some practice in class. Hopefully this stuff is ringing a bell. Remember to jot down any questions that you have. Make sure you ask your teacher, you ask me, or you find your favorite teacher of all time and you ask them, unless they don't know how to do this stuff, and then I would find somebody else. All right, see ya. Bye.